So today we're going to be looking at chain rule again, only today we're going to be looking at problems where there is more than one nested function. When that happens, we say that we need more than one chain. So sometimes we need to use the chain rule more than one time in order to find the derivative. Once again, I'm going to ask that you use different colors while you're taking these notes, at least for today. And then once it's easier to visualize and you're able to understand what's going on a little bit better, you can go back to using only one color when you're writing. So here we go. We want to find the derivative of g. Let's start by looking at the different layers that are in this function. So we have g of t. Now the outer layer here is the tangent function. Inside that layer, we have 5 minus sine of something. And inside that layer, we have a 2t. So now when I try to take the derivative, because there are 1, 2, 3 layers, I'm going to have 3 parts of my derivative. The first part is the derivative of tangent. The derivative of tangent would be secant squared of something. Now remember, what's inside there shouldn't change. So it should be 5 minus the sine of 2t. That inner layer should not change. Then we would multiply by and take the derivative of the next layer. The derivative of the number 5 would be 0, and the derivative of negative sine would be negative cosine. Once again, remember that inner layer shouldn't change. Leave whatever is inside alone. So the 2t doesn't change. Lastly, we take the derivative of the 2t. The derivative of 2t is just 2. Now at the very end of the problem, all I'm going to do is rewrite this in a slightly nicer looking way. So if you'll notice, we have a negative sign here, and we have a 2 here. Those are both going to move to the beginning and act like coefficients. So negative 2. Then the secant squared part with all of that stuff inside of there can go next. Then the cosine with all of that stuff inside of there can go last. And we're done. Okay, let's try a couple more problems. So problem number 1 here. You'll notice that we have a big 5th root. Personally, when I rewrite this, and again I'm going to use different colors for the different layers, I'm going to change the 5th root to a 1/5 power. And that is the entire outer layer. Now the next layer would be the something squared minus 2. We have something to the 2nd power and we are subtracting 2. And the innermost layer would be negative 3x cubed plus 4, because that is inside of a squared function. Now we're going to take the derivative. For the first part, I'm just going to drop the 1/5 power, and I'm going to change it to a negative 4/5 power, because I'm subtracting 1. Now the inner stuff isn't going to change. So something squared minus 2 won't change, and negative 3x to the 3rd plus 4 won't change. Everything that's inside there stays the same. Now for the next layer. I'm going to drop the 2, leave the inside stuff alone, and the derivative of minus 2 would be 0. Now remember, I'm leaving the inside stuff alone, so negative 3x to the 3rd plus 4, and the new power would be a 1, but I'm not going to write it. Lastly, the innermost layer, so negative 9x squared, and I'm done. My final step here is just going to be to make it look a little bit prettier. So the 1/5 here, which is a coefficient, the 2, which is a coefficient, and the negative 9, which is a coefficient, are all going to move to the beginning. So I'm going to have negative 18 over 5, because negative 9 times 2 is 18 times 1/5. And I'm just going to copy down everything else. As you can see, I took up some of my room that I needed for problem 2, so I'm just going to go like that. Woo! And I'm going to rewrite my problem down here. We got a lot of layers here. I'm like a parfait. I have layers. So the outer layer would be a negative 5 power. Inside there, we have something to the negative 4 plus 5. And that something is x squared plus 4. Now I'm just going to take this derivative one layer at a time. I'm going to drop the negative 5, and I'm going to make it into a negative 6, because negative 5 minus 1 becomes more negativer. Now I'm going to leave all this inside stuff alone. Nothing here is changing, because I can only take care of one layer at a time. Now the next layer would be drop the negative 4, make it a negative 5 power, and the derivative of plus 5 is 0. And again, what's inside there doesn't change, so x squared plus 4. Last but not least, the derivative of the x squared plus 4 part, which is just 2x. Now I'm just going to rewrite this in a way that makes it look a little bit nicer. So I'm going to take the negative 5 and the negative 4 and the 2x, which are all kind of like coefficients. They just kind of are all floating out there. We would have negative 20, positive 40x. Leave the rest of it alone. And you're done. Okay, I'm really hoping that this isn't freaking you out yet. We will practice this a lot of times tomorrow in class. Let's try a few more problems. There's only 3 more we're going to do on the next page, and then we're going to do a lot more practice tomorrow. So for number 5, we're going to make our layers different colors. So cosine would be one color, sine would be another color, and the third color would be 5x to the 5th, which is inside of the sine function. Now we're going to take a derivative. The derivative of cosine would be negative sine. Leave all the inside stuff alone. The derivative of sine would be cosine. Leave the inside stuff alone. And the derivative of the inside stuff would be 25x to the 4th. Now, you can leave it like that if you want to. If you wanted to, you could take the negative here and the 25 and move them out to the front and make it negative 25x to the 4th times all that other stuff. But honestly, I don't really see a reason to do that. That's good enough for me. All right, number 9. Now, this one is going to be a little bit trickier because there's a product rule going on here. In the second part of the product rule, we have 2 layers. Something to the 4th power, and what's inside there would be negative 4x squared minus 3. So here's the first part of my product rule, and this would be the second part. And the second part has layers. Product rule says, copy the first one. Take the derivative of the second one. So I would drop the 4, leave the inside alone, times the derivative of the inside would be negative 8x. This whole thing right here is all the derivative of the second part. It's all one derivative. So now I'm going to put a plus sign. I'm going to copy the second part, which is negative 4x squared minus 3 to the 4th power, times the derivative of the first part, which is 9x squared. Now let's simplify a little bit. And it is important that we practice algebraing and simplifying here because on the AP test, when it's a multiple choice question, you want to make sure you can identify the correct answer choice. I'm going to take the 4 and the negative 8x and move them to the beginning. So negative 32x. And then I'm just going to copy down the rest of the problem. So I'm going to have 3x to the third plus 1 times negative 4x squared minus 3 to the third power. Plus, now I'm just going to take the 9x squared and move it to the beginning. Negative 4x squared minus 3 to the fourth power. Now you're not done yet. A lot of times on the multiple choice portion of the AP test, they will not leave the answers like this. In this problem, we really have two big terms, and I mean really big. This is the first term, and this is the second term. They are separated from each other by a plus sign. What we're going to do is look to see if they have anything in common. So before we do this, I want you to look at a slightly simpler example. If you had 3x cubed times y plus 6x squared, their common factor would be 3x squared, and what's left would be x times y plus 2. You're taking out what they have in common, and you're leaving the leftovers inside of a parentheses. We're going to do this with this. So let's look at what they have in common. The first term has a 32 and the second term has a 9. There are no numbers that go into both 32 and 9, so we're good. Now this term has an x and this term has an x squared, so we can take out an x. This term has a parentheses 3x cubed plus 1. This term doesn't, so we can't take out any of those. This term has 3 copies of negative 4x squared minus 3. This term has 4 copies. So we can take out 3 of those copies. Now let's look at what's left over. For the first term, we took out the x, so the negative 32 is still there. We did not take out the 3x cubed plus 1, so that's still there. We took out all of the negative 4x squared minus 3, so we took out all 3 copies. In the second term, we took out the x, so we would have 9x. Then we took out 3 copies of this parentheses, so one of those copies is left over. This is what they had in common. This is the leftovers. Now we're just going to simplify. So we're going to leave this part out here. We're going to distribute the 32. So we're going to have negative 96x cubed minus 32. And we're going to distribute the 9x. So we're going to have negative 36x cubed minus 27x. Inside of this parentheses, we have some like terms. We have the negative 96x cubed and the negative 36x cubed. So my final answer here would be x parentheses negative 4x squared minus 3 cubed. Negative 96 and negative 36 is negative 132 x cubed. And then I'm going to copy down the minus 27x and the minus 32. And this is my final answer. Now let me be clear here. The only calculus part of this problem is this step. Everything after that is algebra. Now it's hard algebra, but it is algebra. So I understand that this is going to be a challenge, but we can do it. Number 10, you can see, is a fraction. So we're going to need to use quotient rule. And if you look carefully, the top part of this quotient has layers. X cubed plus 4 is inside of a fifth power function. So when we use our quotient rule, we're going to have chain rule built in there also. We're going to have low, which is 3x to the fourth minus 2, d high. So drop the 5, leave the x cubed plus 4 alone, and make it a fourth power. times the derivative of the inside would be 3x squared. Low d high minus high, x cubed plus 4 to the 5th power, d low, which would be 12x cubed, and low squared goes down below. Now let's simplify. In the first term here, so again we have two terms, this guy and we have this guy. In the first term here, I'm going to take the 5 and the 3x squared, and I'm going to make it 15x squared times 3x to the 4th minus 2 times x cubed plus 4 to the 4th power minus. I'm going to move the 12x cubed to the front. So 12x cubed times x to the 3rd plus 4 to the 5th power all over this guy. Now let's do the same thing to the top here that we did up here, which is look for a common factor. The number that goes into 15 and 12 would be 3. He's got an x squared, he's got an x cubed. I'm going to take out an x squared. This term has a 3x to the 4th minus 2. This term doesn't, so I can't take that out. X to the 3rd plus 4 to the 4th power, x to the 3rd plus 4 to the 5th power. So I would leave it as x to the 3rd plus 4 to the 4th power. Now let's look at what's left over. I divided by 3, so I have 5, took out the x squared, did not take out the 3x to the 4th minus 2, took out all of these. Minus, divided by 3, so I have 4, only took out 2 of the x's, and I have 1 copy of x to the 3rd plus 4 left over, all over 3x to the 4th minus 2 squared. Now if I distribute on the top here, I get 3x squared, x cubed plus 4 to the 4th, and I get 15x to the 4th minus 10 minus 4x to the 4th minus 16x, all over 3x to the 4th minus 2 squared. And then if I just combine like terms, I'm going to have 15 minus 4 would be 11x to the 4th minus 16x minus 10 all over 3x to the 4th minus 2 squared. And you're done. Now, do I know that this is a lot? Yes. Am I going to give you 10 of these? No. But you will have at least 1 or 2 or 3 of these on your test where I expect you to algebra till like it's over. So it's going to take some determination. We're going to practice this a lot tomorrow. You can do it. I believe in you. I'll see you tomorrow in class.